The Atacama, squeezed between the Andes and the Pacific coast of Chile, is the oldest and driest desert on Earth. Part of its hyper-arid core might see rain only once in 2 decades. Since the early 21st century, international teams of scientists have studied the surprising richness of life in the Atacama's extreme conditions as an analogue model for the possibility of life on Mars. The region's dark caves approximate the last refuge used by life in an ever-drying planet. In the Atacama's coastal range, where the sole source of life-sustaining water comes from low-hanging clouds captured in nets by the region's indigenous people, scientists have found microalgae harnessing the water they need for photosynthesis from condensation on spiderwebs. Scientists reason by analogy. In all that survives the dryness of the Atacama, they seek the possibility of life beyond the bounds of the only human planet. Our best analogy to Mars has a surprisingly busy history of human exploitation. In the last quarter of the 19th century, caliche, the rock of the Atacama, became the world's leading source of nitrate fertilizer for agriculture. The lucrative substance had provoked the War of the Pacific from 1879 to 1883, in which Chile defeated its neighbours, Peru and Bolivia. After the war, and with extensive British investment, the caliche was blasted from the desert surface, crushed, dissolved, and separated by indentured workers from Chile, Bolivia and Peru, who then cleared the debris by hand. A railway line cleaved the desert, its rolling stock and coal imported from Britain, to take the desert rock to steamers bound for Europe and America. Only during the First World War, with sea lanes blocked and the synthetic Haber-Bosch process able to produce at greater scale, did Chile's boom come to an end. Left behind in the Atacama were the scars of extraction. The study of Earth's most extreme environments as analogues to other planets draws our attention back to the conditions that have made this one uniquely hospitable to life, and, in the Holocene era of relative climatic stability over 12,000 years, uniquely hospitable to human life. That, in turn, brings the shock of how many of those enabling conditions are now in peril. In the mid-2000s, Johan Rockström of the Stockholm Resilience Centre and colleagues around the world proposed a set of planetary boundaries that, if transgressed, would imperil the planet's life support systems. Already exceeded our thresholds of danger for biodiversity loss and species extinctions. We have left far behind the safe limit of interference with natural cycles of phosphorus and nitrogen. Of rising concern are the levels of synthetic organic pollutants, heavy metal compounds, and radioactive materials in the oceans and in the atmosphere for which safe limits have not even been defined. The health of 3 vital ecosystems, the Amazon rainforest, Siberian permafrost, and the Greenland ice sheet, is so consequential for planetary processes that any further attack on their integrity risks provoking sudden, non-linear changes in climate and sea level. All 3 are under strain, at least in part, because of another boundary that has been broken, the tolerable limit of human-induced climate change. A silent boundary crossed. In May of 2014, atmospheric concentrations of carbon dioxide crossed the threshold of 400 parts per million for the first time in several million years. The following year, that level was exceeded for the whole month of April, and in 2016, even the lowest reading for the year was above 400. When regular measurements first started in 1958, the level stood at 316. The average level in pre-industrial times was around 280. The threshold of 400 parts per million is an arbitrary number, but we humans trade in symbols. This one was a signal that the impact of human activities on the Earth's climate was bigger and faster than was compatible with the concerted efforts over those same years to reach a binding international agreement to limit planetary warming. The measurement was taken at the Mauna Loa Observatory on Hawaii, established there by Charles Keeling in 1958 as part of the International Geophysical Year. Its location was chosen to provide the closest thing to a representative sample of the planet's atmosphere, an amalgamated, placeless global air unmarked by traces of local pollutants. Mauna Loa sits above the marine boundary layer, far from a major centre of industry and population, but still in the northern hemisphere, where the majority of human beings live. The threshold of 400 parts was crossed without being perceptible to any group of people, only visible to the technicians reading mass spectrometer analyses of flasks of air sent from Mauna Loa to Boulder, Colorado by US mail. Similarly, none of us knew when exactly in 2007 another arbitrary boundary was crossed, and half of the world's population officially lived in cities. Other manifestations of that change in planetary state were only too visible. Every summer hotter than the last. Once in a century storms every 4 or 5 years. Animals experience these extremes as confusion, a scrambling of their sense of place and their expectations of the world around them. Fleeing unusual heat and unseasonal rain, many species are moving poleward and to higher elevations only to find their avenues of escape blocked by roads and settlements and mines. Land-based species confront a bewildering mismatch between sunlight and temperature, muddling the clues they rely on for survival. In the forests of the western United States, the balance of tree species is shifting toward those better adapted to warmer climates. But this process, known to ecologists as thermophilization, is advancing 10 times more slowly than the climate is warming, so that western US forests are becoming mismatched with their environments. The forests find themselves in a new and unfamiliar world. No corner of the planet has been untouched by species migrations. Crabs invade the continental shelf habitat of Antarctica to the detriment of seafloor echinoderms and mollusks. Kelp forests in Australia give way to seaweed turfs, reshaping the web of aquatic life. Across Europe and North America, heat waves have diminished site occupancy and species richness in colonies of bees that play an indispensable ecological role as pollinators. At the limit of adaptation lies the path to extinction. The checker spot butterfly has vanished from the San Francisco Bay Area, driven out by the increased variability of rainfall. In Mexico, 48 species of lizard have disappeared as maximum air temperatures exceed the limits of their endurance. The Adrar mountain fishes in Mauritania have not survived the evaporation of local water bodies. The Yangtze River dolphin, or baiji, poor in eyesight, rich in hearing, and beloved as the river goddess, was last seen in the wild in 2006, driven to its doom by noise, water traffic, and pollution. In the oceans, which yearly absorb about a quarter of the carbon dioxide that human activity generates, the years between 2014 and 2017 witnessed the most severe and widespread episode of coral bleaching ever recorded. Intense heat stress sunders the symbiotic relationship between coral and microscopic algae called zooxanthellae. The coral expel the algae in an act of desperation that turns into self-harm. If conditions do not soon return to tolerable margins, the coral themselves die. Coral death reverberates across species: sea turtles, fish, crabs, shrimps, jellyfish, and seabirds. We live in the midst of a universal redistribution of life on Earth. Human bodies, too, struggle to cope with new extremes. For at least 20 days each year, a third of the world's population is already exposed to heat exceeding the deadly threshold at which the human body ceases to regulate its own temperature. Around 19% of the Earth's surface was affected by drought in 2020, a proportion that never exceeded 13% between 1950 and 1999. As temperature and humidity shifts, so too does the geography of threats to human health. Cases of mosquito-borne arboviruses, dengue, chikungunya, and Zika have doubled every decade since 1990. Cholera, the great scourge of the 19th century, has seen a resurgence. The very air we breathe bears harm, almost 2 centuries after the first smoke nuisance legislation. In February 2013, 9-year-old Ella Kissi-Debrah died of acute respiratory failure in London after repeated bouts of asthma. She lived just off the South Circular Road in Lewisham, one of the city's poorest boroughs. On her walk to school every day, she breathed nitrogen dioxide from vehicular emissions far in excess of safe limits. After a long struggle for justice led by her mother, Rosamond, and supported by clean air activists, a coroner's court ruled that traffic fumes had contributed directly to Ella's death. It was the first time in Britain and possibly in the world that air pollution was listed as a cause of death, though toxic air contributed to more than 4 million premature deaths worldwide in 2019 alone. The most poignant remark made by Rosamund Kissy-Debrah at the inquest was that if she had only known how dangerous the air was that her daughter breathed every day, she would have moved without hesitation. The question around the world is where people can go for respite and refuge. The International Organization for Migration estimates that between now and 2050, 1 billion people will be displaced from their homes by the effects of climate change. In South and Southeast Asia, in parts of Latin America, and across much of sub-Saharan Africa, unprecedented peaks of heat, prolonged drought, more intensive storms, and sea level rise are pushing many regions to the limit of ecological viability. Indigenous communities inhabit some of the most vulnerable edges, including the Yanomami of Amazonia, the Inuit in the Arctic, the Sami in Scandinavia, and the inhabitants of low-lying Pacific island nations. In the global north, media coverage of climate migrants often imagines them clustered at the gates of the wealthiest countries, demanding to be let in. But doors are closing in an era of racialized hostility to migration in the world's richest countries. The overwhelming majority of people who are forced to leave their homes by aridity or deluge will move within the borders of the countries where they live, almost all of them in the global south. Most people who do cross an international frontier will cross the closest one to where they live, at risk of harassment by border guards and menaced by electrified barbed wire fences. Throughout human history, migration has been a lifeline for communities facing sudden or prolonged changes in the ecologies that sustained them, often in the form of temporary movement over short distances. There is an odd historical echo to recent discussions of climate change and migration, for in the 19th century, too, many observers saw non-white migration as driven entirely by droughts and fearsome typhoons. And the use of liquid metaphors to describe migration still permeates even the most well-intentioned writing, a language of floods and tides and waves. But migration is not, or is no longer, an option for many people. The poorest people within the regions in the world most acutely vulnerable to the impact of climate change lack the experience, access to credit, and accumulated family connections that make long-distance migration possible. The slow effects of climate change are at least as likely to leave poor people stranded, unable to move, as they are to spark a rush of climate refugees. Others steadfastly refuse to move. For many people around the world, the prospect of having to abandon lands of meaning where ancestors are buried is simply unimaginable, all the more so for communities that lost everything to the onslaught of colonial settlers. Anton Chekhov had seen in Siberia 150 years ago just what it takes to decide to leave home, to sacrifice for this one's own locality, one's own beloved domestic nest. In the more recent words of the Somali-British poet Warsan Shire, no one leaves home unless home is the mouth of a shark. Amid an existential inequality in the conditions of life, the most privileged part of humanity has fortified its place on Earth. An arsenal of nature-dominating technology upholds their freedom from nature's constraints. A technosphere of buildings and bridges, cables and tunnels, mines and plantations, laboratories and hospitals, factories and satellites, roads, railways, ports, airports. Since the mid-20th century, it has grown unfathomably large, with a combined mass of 30 trillion tons, including 11 trillion tons of urban settlements, the largest proportion, 3.76 trillion tons of cropland, and 2.25 trillion tons of ocean floor that has already been trawled for minerals. Buildings account for 40% of global energy-related carbon emissions, and homes alone account for nearly a fifth. Construction consumes almost all the world's cement, half of all the steel produced, and around a quarter of aluminium and plastics. No part of the planet lies untouched by the technosphere, but, like fortifications of old, it is built to keep people out as well as to protect those within. Around the world, 1.6 billion people live in housing that the United Nations Human Settlements Programme describes as inadequate, while an estimated 100 million people have no housing at all. China now plays a leading role in building the technosphere. The Belt and Road Initiative, launched by President Xi Jinping in 2013, is the largest infrastructure project the world has ever seen. It aims to connect Eurasia through highways, high-speed rail and oil and gas pipelines in a sped-up repetition of the 19th century's steam-powered globalization. In the 10 years since its launch, the initiative has reached 147 countries, generated $596 billion in construction contracts, and now accounts for 45% of world trade in merchandise. It has also given China effective control over the materials required for the Technosphere's further expansion, including 80% of the world's graphite and half of the world's capacity to process lithium, nickel, and cobalt, along with colossal amounts of fossil energy. The armed defense of the Technosphere is itself a driver of environmental harm and a behemoth in the way of effective action to curb it. The world's militaries contribute up to 5% of global carbon emissions, and the secrecy and opacity of their reporting means that figure could be even higher. The US military contributes the most by a substantial margin, and the US government has lobbied hardest to ensure that military emissions remain outside the ambit of international agreements. The military imperative to secure shipping lanes for the transport of hydrocarbons emboldens the corporate lobbyists who influence government policy, thwart regulation, and spread misinformation. The most grievous of environmental injustices is that the communities, countries, and whole regions that have done least to cause planetary warming are often most vulnerable to its effects. Their vulnerability is compounded by the unequal way the Technosphere casts its shield. The more damaging its own impact on Earth systems, the more necessary the Technosphere becomes to human well-being, and those outside its protective sphere grow more and more exposed. In Paris, at the end of 2015, the governments of 196 countries signed a legally binding agreement to limit global warming to well under 2 degrees Celsius, and preferably not exceeding 1.5 degrees. The powerful advocacy of small island states impressed on the gathered delegates that climate change was no longer a distant risk. In his speech at Paris, Gaston Browne, Prime Minister of Antigua and Barbuda, insisted that island nations faced an existential threat. He quoted the St. Lucian poet, Derek Walcott, "A morning could come in which governments might ask what happened not merely to the forests and the bays, but to a whole people." The Paris Agreement fused moral urgency and messy compromise. Each party to the agreement agreed to an obligatory yet unenforceable and self-determined contribution toward reducing global emissions to net zero by 2050. Even if every national target were met, they would cumulatively fall short of the reductions necessary to meet the agreement's stated temperature goals. But the accords made substantial progress where previous climate summits had ended in acrimony. Though thin on specifics, the Paris preamble made reference to environmental justice. Countries of the global north pledged funds to help lower-income countries reduce emissions without placing even heavier burdens on the world's poorest people. And in Paris, a door inched open to discussing what has come to be called the loss and damage suffered by countries that have made a negligible contribution to cumulative greenhouse gas emissions, but which now face a double burden from the effects of climate change and the rising cost of alleviating it. The goals of the Paris Agreement, though many activists feel them to be too modest, will still require changes so rapid and far-reaching as to be unimaginable without new technologies. Many hopes and billions of dollars in investment are lodged in substitutes for hydrocarbons. The largest scale response to climate change has been the dramatic rise in the availability and accessibility of renewable energy over the past 10 years. Solar capacity increased by an average of 20% every year between 2010 and 2020, while its cost fell by 15% annually. The increase in onshore wind farm capacity was not far behind, with a 12% yearly increase. Without the continued and substantial expansion of renewable energy, there is no possibility that the decarbonisation targets agreed to in Paris in 2015 will be met. Renewable energy presents a promising but not uncomplicated path to slowing the pace of planetary warming. Renewables will reduce greenhouse gas emissions, but might do so by deepening human inequality and harming biodiversity. To generate as much electricity as a 1 gigawatt fossil-fueled power station, an array of photovoltaic solar panels needs about 80 square kilometres of land. In India, sprawling solar parks have seized land from small farmers and pastoralists in a manner that is uncomfortably reminiscent of the way large dams displaced millions in the 20th century. Advocates respond by promoting symbiotic solar. Panels are raised above farmland, sheltering root vegetables and leafy greens that grow underneath. Or they are built on stilts above grassland grazed by sheep. These technologies are unlikely to be within reach of farmers that barely own any land and struggle for access to water. And a further land grab is underway in ecologically imperiled lands for the rare earth minerals that solar panels and batteries devour. Less proven, more expensive, and considerably riskier are efforts to capture carbon at the point of emission, and even to remove it from the air. Some carbon capture technologies are decades old, but their potential role in achieving climate goals has brought a surge in public and private investment. The most effective strategy has been to use amines to scrub the CO2 from smokestack emissions, cutting the carbon impact of power plants and factories. By contrast, technologies of direct air capture are costly and have mostly failed to deliver on their promises. The most widespread use of the extracted CO2 remains the oldest one, to repressurize depleted oil wells to force out more hydrocarbons. Carbon capture might yet increase the production of fossil fuels, delaying and obstructing more fundamental changes in consumption and energy use. The carbon that is not reused is sequestered underground, drilled deep and sealed by layers of permeable rock. But that seal, many scientists warn, is not necessarily permanent. It is prone to slow leakage, and also to spectacular failure, as with the Aliso Canyon gas leak in California in 2015, where a burst pipeline released 97,000 metric tons of methane into the atmosphere. At the outer frontiers of technical possibility, a growing group of scientists argue that the only way to stall climate change fast enough to prevent catastrophe is to extend the technosphere as far as it will go, to engineer the climate itself. Solar geoengineering would inject aerosol particles into the stratosphere to reflect the sun's radiation back into space. When the Pinatubo volcano in the Philippines erupted in 1991, it spewed 20 million tons of sulfur dioxide into the upper atmosphere and cooled the planet by an average of 0.5 degrees Celsius over 2 years. The supporters of geoengineering, with a stronghold at Harvard University, propose to replicate this effect by design. With every target for reducing emissions missed, with the Earth on the brink of runaway warming, proponents of geoengineering argue that it is a radical solution worth considering. The unintended, often disastrous effects of the 20th century's attempts to engineer environments suggest the need for precaution. Critics insist that solar geoengineering is profoundly risky. Its use could alter patterns of rainfall, disrupt broader climatic systems, and trigger extreme events, though the geoengineers would point out that all of these things are happening already as a result of climate change. In the absence of agreed standards for regulation, the unilateral use of geoengineering is also likely to trigger international conflict. Even if the technology were perfectly calibrated, it bears the dangers of the quick fix. Solar geoengineering might alleviate climate change while leaving intact every other dimension of the environmental crisis: species loss, the depletion of fresh water, assaults on the forests and the oceans, and reducing the incentive for the wealthy and the powerful to change their behavior in any way. It epitomizes the furthest extension of the hubris that human beings can conquer nature. Well-intentioned critics present a misleading picture of solar geoengineering as a project forced by elite scientists in the global north upon an unwilling global south. That is, at best, a partial view. It underestimates, for a start, how fully China has embraced the prospect of weather modification. Most ambitious is a 2016 scheme to burn silver iodide to inject into clouds, creating a sky river, Tianshan, of forced precipitation that would turn the atmosphere itself into a sort of pipeline, mirroring in the air the mammoth terrestrial south-north water transfer project to shift water from the Yangtze River to water-stressed North China. If the Sky River has subsequently vanished from public discussion, it nevertheless signals an openness to climate engineering on a grand scale. Chen Ying at the Chinese Academy of Sciences is China's leading advocate for solar geoengineering. She makes the case that radical measures may be necessary in response to the climate emergency. She also argues that China has no choice but to keep abreast of developments, or risk becoming a victim of the unilateral use of those technologies by the United States. Since the mid-20th century, post-colonial nations have been at least as attracted to top-down technological solutions as have wealthier countries, if not more so, given how much ground they felt they had to cover to catch up. There is some evidence that climate engineering enjoys broader public support in the global south than in the global north. The fear in poorer countries is not necessarily that they will be forced to accept tools to control the climate, but just as likely the opposite, that they will be excluded, with no say in the deployment and development of geoengineering technologies. They have well-founded fears that their voices will be nowhere on the expert panels that decide, for all of humanity, which risks are worth taking. Masked by the allure of planetary silver bullets are hundreds and thousands of smaller actions, and an even greater number of possible future actions to reverse the damage to life on Earth. Urban governments have made unglamorous but substantial improvements to how their cities function. Since the late 1990s, Bogotá, Colombia, has cleaned its air and converted 17,000 square miles of roadway to pedestrian use with a fraction of the budget of European cities that have achieved similar feats. Under the leadership of Mayor Enrique Peñalosa, the city rejected a plan for elevated highways and spurned an expensive subway system. Peñalosa's administration built instead the bus rapid transit, a socially inclusive system of accessible public transportation. Its name, the Transmilenio, Transmillennial, signaled the ambitious transition in urban life that it sought to bring to the 21st century. In 2 decades, Transmilenio has acquired one of the largest fleets of electrified buses in the world. Intersecting with the bus network are more than 500 kilometers of protected bicycle lanes, championed and claimed by a civil society group, La Ciudad Verde, the Green City, without waiting for government support. Beyond crowded cities, the quest to salvage coastal landscapes inches forward. The Indonesian government is in the midst of an ambitious project launched in 2020 to restore 600,000 hectares of mangrove forest over the next few years, mostly in coastal Kalimantan and Sumatra. Mangroves are among the far migrants of the plant kingdom, forever sending their young stages off to establish pioneer colonies. Rachel Carson wrote in 1955, pointing to their ecologically heroic role in creating land where once there was sea. With their rapid disappearance all over the world in the second half of the 20th century, the sea has clawed that land back. Planted seedlings will thrive only where the local soil and hydrology are receptive, and where structures of land ownership give coastal people a stake in the forest's long-term preservation. A vibrant WhatsApp group of Indonesian mangrove scientists buzzes with ideas about the most promising sites for restoration. And so far, they have found a receptive ear in the government. Restored mangroves which shelter fish, turtles, sharks, crocodiles, and in Indonesia alone, 1,723 bird species, being a stopover on the major bird migration route known as the East Asian-Australasian Flyway. Mangroves shore up sinking lands, protect coastal communities from storm surges, and nourish the small-scale fisheries that could enhance the livelihoods of artisanal fishers, while augmenting the food security of 74 million people. Repair is an urgent priority too when it comes to the most harmful of human infrastructures. Every day, the leaky edges of the Technosphere emit a greenhouse gas 30 times more powerful than carbon dioxide. Satellites of the European Space Agency and NASA have sensed previously invisible plumes of methane at more than 2,000 locations around the world. The largest methane emissions surround oil and gas installations in the Permian Basin, New Mexico, and in Turkmenistan. Because methane remains in the atmosphere for only a decade, in contrast with carbon dioxide's lethal persistence, the number of super-emitters could be radically reduced simply by repairing leaks and making aging petrochemical infrastructure more secure. Repairing infrastructure could rapidly reduce harm, though without any of the positive reverberations across species of restoring ecosystems and at the cost of locking in destructive patterns of energy use. Will thousands of small acts of repair suffice to alleviate the cumulative impact of climate change, biodiversity loss, and new threats to human and animal health? Probably not. It is likely that large-scale technological intervention will play a part in sustaining human life within the limits that the Earth's systems will support. New technologies are emerging so rapidly, particularly in the area of artificial intelligence, that it would seem foolhardy to predict which of them will succeed. Almost 1,000 years after the transfer of champa rice seeds spurred a rice revolution in southern China and opened new possibilities for the scale of human life on Earth, our most pronounced impact on the planet still comes from the most foundational of all human activities: growing food. Agriculture accounts for 1/4 of all greenhouse gas emissions. 31% of this comes from livestock and fisheries, 27% from crop production, and 24% land use, of which only 8% is land devoted directly to human food and the rest to livestock. Food production is by far the most important driver of biodiversity loss. Meanwhile, an estimated 1 in 10 people alive today do not have sufficient food to eat, including more than 20% of the population of sub-Saharan Africa, and almost 16% of the population of South Asia. Human inequality determines how food shapes the world. Maldistribution is pervasive. No less than 1/4 of greenhouse gas emissions from food, between 6 and 10% of the global total, come from food that is decayed, spilled, or simply thrown away before human consumption. Food waste, that is, accounts for a greater share of emissions than any single country on Earth other than China and the United States. The first stage of loss is an ancient problem eased but never solved by refrigeration and transportation. The farmers struggled to preserve the harvest from rot. The intercontinental expanse of the trade in food, which emerged with the railroad and the steamship in the 19th century, made it possible for farmers to sell their surplus to distant markets, but also introduced many intermediate steps where food could be ruined. And then came distinctive 20th century problems: food that rots on supermarket shelves before it is sold, food thrown out by restaurants after too much is cooked, food that households forget to eat. If it was once a plague of prosperity, it is no longer. With rapid urbanization, food waste is a characteristic of middle-income countries, as it is of wealthy ones. The need to reduce food waste is mostly uncontroversial. The steps toward it, better information, easier access to infrastructure for small producers, safer and better labelled packaging, and public education, beginning in schools, are quiet, undramatic, and will grab no headlines. But they are eminently feasible. An even more radical shift in food systems is urgent, and it is harder to imagine its success. No single change would have a more transformative impact on the health of the planet than human beings choosing to eat fewer animal products. A widely cited 2018 study published in Science estimates that if everyone alive were to move to an adequately nutritious plant-based diet, we would see a 76% reduction in the land used to grow food, which is the most important threat to biodiversity. We would see a 49% drop in greenhouse gas emissions from agriculture, while acidification would fall by 50%. But food is where technical discussions of climate change solutions, the policymakers' abstract language of reductions and targets adaptation and mitigation, collide with the essence of what it is to be human. The meaning of food is intrinsically bound to history, which alone can tell us why different cultures eat the way that they do, which foods they grant ceremonial value, which they offer to visitors, and which they reject as uncivilized or disgusting. Food has always been a marker and expression of cultural identity, a storehouse of collective memory. Above all, it is a source of joy and comfort. In most human cultures, the foods of greatest importance, the delicacies and cultural markers, are meats, and many European and Central Asian cultures also prize dairy products. Food preferences are deeply rooted but never static. Changes in culinary desire have driven sweeping changes in how human beings have exploited the earth and exploited each other. Most pivotally, in modern history, the European taste for sugar and fine spices. In times of privation, as during both world wars, food habits have changed very suddenly. There are signs that they are changing again in response to ecological concerns. For now, plant-based diets and lab-grown meat substitutes appeal only to a small, wealthy group of urban consumers. Making them more affordable and more culturally appealing could have wider reverberations, for even halving the current consumption of animal products would achieve around 70% of the reduction in greenhouse gas emissions that would come from eliminating them entirely. Given how rampantly destructive it is to the viability of life on Earth, there is a strong moral and political case for advocating for a sharp reduction in the quantity of animal products eaten in the global north, where meat and dairy have been abundant and cheap for 200 years, where per capita consumption has long been above the global average, where industrial farming inflicts vicious cruelty on animals, and where alternative sources of nourishment could be made plentiful, even if currently out of reach for low-income and marginalized communities. With an even stronger insistence on support for the poorest in society, some part of that case could plausibly be made for a country like Brazil, where levels of meat consumption are among the highest in the world, despite massive social inequality. But to apply it to India would be both misguided and politically irresponsible. In India, a substantial proportion of the population does not receive even a bare sufficiency of protein despite rapid economic growth. In India, the forces of Hindu nationalism have wielded a militant vegetarianism as a marker of cultural purity, using it to persecute Muslims and Dalits to the point of public lynchings. Neither justice nor environmental protection would be served by focusing on meat consumption in India. As the largest exploiter of groundwater in the world, India's contribution to addressing the planetary crisis might begin instead with the radical reform of the incentives that lead large farmers to deplete the water table at a rate that is hurtling toward disaster, with consequences not only for water security, but also for the mighty South Asian monsoon. One of the lessons of the 20th century's modernist failures is that global problems are not always best approached with standardized global solutions. To adopt too narrow a focus on carbon emissions, two leading geographers argue, runs the risk that we will extract climate change from its social and environmental contexts, to see it as a disembodied process acting on an undifferentiated world. An important dimension of this tendency to reductionism is the willful ignorance of history. The scale and rapidity of destabilizing changes to Earth systems have taken us into uncharted territory, outside the range of past human experience. But the institutions and the values with which human societies face the future are far from a blank slate. At the first global conference on the environment in 1972, Indira Gandhi made two forceful observations that retained their bite even if her own government proceeded to ignore them. Her first point was that we live in a divided world. She saw, and we see more clearly now, that the uneven forcing together of peoples, plants, animals, and pathogens that began 500 years ago leaves an imprint on the endowments and capacities with which different societies now confront the burning Earth. Her second enduring observation was that efforts at environmental protection will simply fail if they proceed in isolation from social justice. No planetary scheme in the years ahead will be able to detach itself from these stubborn residues of history.